At least. Well, when I was a wrestler, I could eat. When I was eating 1,600 calories, my wrestling diet was 1,600 calories.
That's
So
it.
I could lose 4 pounds, 5 pounds, 6.
Mostly water weight, but yeah.
Yeah, when I was a wrestler, yeah, absolutely. I didn't chew back then.
Do a push-up, with the sweatsuit on.
Is that what you have?
Well, no. Work experience.
I've been there.
I'm not waiting.
Dia saja ada kawan bocah ni yang kata nomor dari mana kan?
Sure. So I maybe hitting you up with wait, that's fine. Or you just take some function. So you just recursively call that function on every node, right?
Well, seriously, where to add this implementation instead of assign value.
Yeah, you're supposed to make a
You call that function, assign the results of that function.
to the node. Oh, so you would do like call like this dot left equals.
How to traverse it.
They're gonna look at your code.
I think I know.
Okay, let's see.
Returns a nutrient.
The actual implementation, so like.
Should be recursively.
That's finished.
You're talking about the bottom.
Yeah, so like all this. It looks like a lot. Yeah, I mean, it looks like a lot, but it's all very.
Oh, you just add the
add
values.
to the new tree, yeah.
Oh, and then you can recursively traverse it. Okay.
I mean, it was kind of lofty.
Yeah.
Night work. Last time I was at like literally one night.
Yeah. For most of it.
So for this one,
The Halloween party. It was actually too much.
that's my daily brightest.
Was this just
Just
like
like
valve and those?
They had like afterwards. So
Yeah, no, that's-
They didn't have the bands.
Yeah, it was just too much for me.
Oh, you
So
went to
you
Halloween
can
party?
also
Yeah.
do that in 1.2,
Yeah,
where
I've
you
been on
call a big string
years.
from that.
Yeah, I know, dude. Hey, you're not a fucking child, right?
Yeah, it was everybody
And
there.
they're free,
They're
the
like,
whole
they were like,
you can have like very
like all kinds
since you're only gonna use it.
Sorry, just like, just fell out.
Yeah. it makes it-
Returns the height.
And hi guys. Nothing here.
Yeah, it's like, oh, one shot.
And you're saying delete Hey, so.
You guys missed Flickr, huh?
It automatically
Yes.
Been a while.
So that would.
Do you even know how Flickr's working on your
Yeah, so when you display that, you want to call that next string, so you can put a print statement. for that.
Yeah, you point that out.
Whoa.
Yeah.
Yeah, yeah. That is cute case on it.
Few review questions related to Haskell.
Oh, no points for me, that's
Function to appear mark the incorrect option. It may produce different results for same input. So that will be an int word function.
Oh.
nice and side effective.
Really hard to see. Huh?
Yeah.
Lecture for the input. To evaluate first, and then I'll show you the options. So the question basically is a yes, no. You have to tell whether fun is pure or not.
What are the answers?
The options are yes or no. A is yes, B is
We can't see the names.
I was like,
this summer I'll be teaching mobile app development. I'm gonna have my students create our own clickers. How about that? Without the limitation of this 5.
Yes, that's actually.
So if you want to do clickers, you should enroll this summer. So it's not pure because you're going to call the same function, the same parameter, but because the function depends externally, depends on why the value will be different. It's going to just return a different value. How would you generate that list in Haskell? Do you guys remember? Haskell has a easy way to create lists based on listed enumerations.
I know the answer.
Last one, so 10. Because we're going to jump by 10, you have to specify the second element. Finger.
There it is. It's good.
Got it?
Yep.
Okay, so the most obvious one is the one that doesn't work. Right? All right. I think that was the last. No, you have the last one. Oh, I'm sorry, Letitia. Never skin Mars. Trying. Okay. Letitia, it worked.
Oh, wait. Crap, I read that wrong.
Can you change your answer?
Sure, you can change your answer. Stefan, move away a little bit. There you go. Still not skating. Oh, you got it. All right. So the assignment will be evaluated, but the list generation will be postponed to when it is needed. It's going to be generated one value at a time as you consume the list. The list will not be generated because of the lazy evaluation feature. Remember that? All right. So last time we were talking about how to simulate functional programming in Java. Also, how Java incorporates functional programming in their streams package. So you can, just a quick review, you can use the concept of interfaces to define function types, right? So basically, a function will be defined by an interface. You can use a generic interface because a functions will be different depending on the input parameter types and the return type. So in order to avoid having you create a different interface for all the possible types, combinations for input, it's best to use generic interfaces, right? So this generic interface here called function is basically defining a type for a simple function that takes just one parameter of type T and returns a value of type R. Okay? And you can use this type of definition to implement functions like triple function. So the triple function, so triple now has a type. And the type is defined by the function interface. And the input will be an integer, the output is also going to be an integer for this case. And I'm going to give an implementation for this triple function. And I'm implementing here this function type. And I need to override the call method. Yes?
So my question is, and you can finish the end of the slide if you like, but if you're going to implement function, what we saw in the last slide with the generic in an interface. And then where this function is defined with the override is going to be implemented in a main class that implements that interface.
Yeah, so the interface is basically, it's not the function itself, is the definition of the function's type.
It's the template.
Yeah, like a template for the function, exactly.
Okay.
The actual implementation you have to specify, because using this template, you can define many functions, right? You can define the triple, the double, right? Many different functions that have in common having just one parameter and one output. So this template, as you're saying, it doesn't work if I want to create a function that takes two parameters, right?
You have to define something else in the interface.
Yeah, I will have to create a different interface, okay? Okay, so I'm instantiating one function called triple, and this function, the call implementation, is going to multiply the given parameter by 3, and we'll return that back. And I can use now this function's instance, right, to using another function called map. So this map function is what we were discussing. It's a type of a higher order function. You can say that because it takes a function type, right? The second parameter is a function, right? And this function is basically, so the parameter has to be, so f is of type function taking an integer and returning an integer, and it will apply, we'll call, right, on each of the elements of the given list, right? And that will be used to create another list, and this list is returned by map. So pretty much the definition of map that we discussed previously, right? But now simulating that using Java. This is how you use. I agree. I don't know if you agree with me, but it's you have to basically, because Java doesn't provide the function as a type by itself. We have to use other mechanisms available in Java to kind of simulate that. So it's a lot of work, right? But at the end, using it looks like what we have been showing, right? So it's hard to implement, but once you have that implemented, the use is very similar to what we have seen in Haskell or Scala, for example. These interfaces, you don't have these general proposed function interfaces. You don't have to implement them, or you don't have to define them. The Java Util function package contains those templates for you to use. Another way to use function programming in Java, this is newer, is using the stream package. So the stream package allows the use of lambda functions. So lambda functions were added later in Java, and it basically allows you to specify functions that can be written as a single expression, okay? And this is, so very simple functions that you can write in just one line, one expression. And the syntax is, if you have just one parameter, so you have parameter and then arrow in the expression. So lambda functions, they don't need a name, so they're unnamed function. Very has a very syntax just to allow you to represent these write these parameterized expressions. Let's put it this way, as when you call, for example, map and filter those higher order functions by using lambda functions. Lambda functions provide an easy way to specify those function parameters for map, filter, and other higher order functions. If your lambda function takes more than one parameter, you have to enclose them in a tuple-like syntax. Okay. And here's just illustrating how to use Java functional programming. If you're using the stream package, basically you can get a stream from a list. So what is a stream? A stream is basically it provides a mechanism that allows you to consume a collection one item at a time. So from a list, from a collection, you can call stream, and your stream will be of some type, depending on your collections type. So if I want to use a list in a map function, I have to first get a stream from my collection. So this is the stream in, and here I'm basically defining a triple function and using the toInt function interface. So this is defining the function package, and it has apply as int. So similar to the interface that I showed before, but this is coming from this. I didn't have to define this interface. It comes with Java, toInt function. So basically, it's a function that takes an int and returns an int, because apply as int returns an int. So now I want to use maps. So I'm gonna, using the stream, the input stream, I'm gonna call map, and I'm gonna pass a lambda function parameter. So S is the parameter, and the expression is to call triple apply as int method defining triple. Okay. This is such an easy function that I didn't have to do all that. The expression could have been replaced by 3 times x2 or 3 times s, right? 3 times s also works. So let's look at the activity that I think we started, right? Last time. Activity 16. You guys need time to try this? Or did we start that last time or no? Okay, so I'll give you time to work together, see if you can figure out based on the slides, try to figure out how to implement those things, okay? Steps 1 to 3, it's assuming that you're gonna do everything from scratch, okay? So you're gonna create the interface, you're gonna create the filter function, all that. Step 4, you're just gonna do the same steps, but the same functionality, but you're going to implement using the stream package, okay? So you see both ways. I'll give you some time to do that, so we can talk about it, okay? We'll work on activity 16, right? Remember, this is Java, okay? It's gonna be the first project we do in Java this semester, right? So if you're using IntelliJ, I know you're used to Scala project. No, do a Java project, okay? Plain old Java.
I was asking if he was doing a Java or a Scala project.
Feels so good when you guys use this monitor. It's like we're actually using this resource.
Getting our money's worth.
Getting our tuition for it.
It's like the student fee, right?
Yeah, I did.
Pretty good.
All of my life wasted playing.
That's a lot. Fun job. When you remember. Java.com.
Dude, that's
Yeah, I think it's supposed to be a number case. I just got good at it.
Well, see, I was playing classes where you just hold your face on your keyboard. Just press all the buttons. This one.
It's a bit of. You should probably make an interface.
That's a terrible idea. Why would you do
It's so long since I touched Java.
that? Because they have that interesting
Never made it.
interface keyword, so I'm thinking
This weekend.
you need,
Oh.
do you need to make an interface? It looked like I was using the interface keyword.
Call it predicate.
Yeah, could you just do?
Generic type T.
Yeah.
Arrows. Line one.
No, line one, bro. Line one.
After predicate.
It has to be generic.
Yeah, there you go. Oh, yeah. It's slowly coming back. Find the test takes it to that.
The return type you can assume it's Boolean, right? Because it's the predicate, so you don't have to parameterize the return type.
It's a public Boolean test.
Bro, I got froze up in my coding interview recently, and I was like, I don't know how to make a class.
Trophies. No.
I was like, I know what you want me to do. I'm freaking out. It's so bad, dude. It's
Bro.
hilarious. It's hilarious. Yeah.
Yeah, buddy.
And then,
You got it.
no.
Public Boolean test takes a type T. T value. T value. Yeah.
Oh, crap.
T value. Obviously.
It's in brackets, right?
Well, but you can't define anything else.
What does it
Return
say?
true.
You can't put anything at the body or.
And then just write it to do. That's what you do.
What do you mean you can't do anything with the
Lowercase
body?
t.
But why is it using
Oh
an
my
error?
god.
It's giving you an error because interface abstract methods cannot have body.
Oh yeah, that's right. Just put a simple. Why are we writing it? What's the interface? The body of the code. Just put a simple in it. I remember. I'm done.
It's been a while. I don't know what's gonna happen with that.
Okay,
Also public is redundant.
so go ahead and make a public static void main.
Top did that.
And the other file.
Oh, the other file.
Yeah. Okay, and then also in here, you need another static method. It's called filter. So, no, like inside the class, but outside this method.
So in predicate? Oh, here.
Okay, so they call it filter, takes a list, and return the list. So, public list filter. It takes
The filter's supposed to filter it by.
and it takes a predicate.
parameter.
Let's take predicate too. It's the problem with predicate.
So how did you?
Predicate has to have a type T.
Well, no, it's going to complain about type T because T is undefined.
Yeah,
It
T
wants
is
you
not
to-
defined here.
It wants you to define what predicate is.
Get rid of that. I don't think you
Where's your intelligence?
Well, but filter takes it as a parameter.
Okay.
Filter takes the predicate as a parameter, or?
Yes.
Open your body.
That sounded.
That sounded wrong.
Open your body, Adam.
Okay, so don't flash me. Please.
I'm in a perfectly professional environment.
Yeah,
That was
so
my
move
work.
through and move through the list. We need a new list too. Make a new list.
The outer type in the file. Yeah, very outer type.
Of type what?
Since when is
This
Java?
is not pair programming, it's quintuple programming.
This is what?
That's why I asked. Type
Quintuple
what?
programming, 5 programming.
So that means if I.
Takes at least 5.
So 2
I'm thinking
navigators, 3
3 drivers.
drivers.
You need a lot of pedals in this car.
Lots of brakes.
Yeah,
Lots
mostly,
of brakes.
mostly brakes.
I thought that
You should
list,
make a.
this is supposed to be a new thing in.
You make a list in main,
What?
not in
It used to be
filter.
list was abstract and you couldn't implement just list. You have to give a type.
Well,
Yeah,
but he
This is
imported.
list, that's why
You do.
got that.
Yeah, sure.
You have to make it up.
It likes it somehow. People, well, until you get your
It doesn't,
new array list or something.
Yeah. Exactly.
well, but
Okay, that's enough. So colon. And next we need a loop.
Okay, so this
The other list.
interface should be generic.
So we can do, or should we do?
wow, it's, why is it complaining about all of my things? but it's not complaining about
No,
you?
No, you can't, because there's no indexing in a list.
But it has a
So it
size.
has to be a for each. Yeah, what I'm saying
What
is,
is
you
that?
have to use dot
Yeah,
get, which is terrible.
Can be an integer float.
That'd be in square time
Depending on what
complexity,
you
you get
pass
dot
in,
get.
what do you want?
Just do a for each loop.
Oh, for each is.
It's like two.
I'm gonna go
For
work
each
there.
just iterates through everything which is one.
Yeah.
That's what we want.
Yeah, I don't know why. There's that.
Wow.
Must be a syntax somewhere. This is how they code. That's where difference comes from.
Do I have to?
Why do they do that? Have you ever seen
interface?
it like that? That's the template default.
Look at ours.
So, well, I mean, okay, I've definitely seen it like that. If you have like an interface thing.
Yeah.
Structure, like, just.
That's true. So multi-lines were in the real world, while the Java is ugly and all.
Well, yeah, I mean, how else are you gonna iterate through each I abstract B factory implementation?
It's because
So
says make credit.
I was not prepared for what the fuck you just said.
What's a bean factory?
That's the point.
These are just random.
Okay, so-
words
so-
or
I think that's what's not.
It's
a
a
Hello World Enterprise element.
For, well, you have to give it a type, right? So
My body is ready.
that's the issue here.
What are we trying to do?
This is like a list.
Can we do it a different way, please?
Can you do a formula to make this easier?
Or get rid of all this, just do lowercase list,
So I need to
dot for each.
Instantiate hello world thing class.
Arrow, that arrow.
Oh, man, hello
Oh,
world.
wait, no, it's skate arrow, I'm sorry.
You don't get the body.
Oh, man.
It's just.
I'm gonna say
Fix the bell.
open curly braces. And so here, we're gonna do a body.
So you can
Why is it easy to get out?
Okay, so we're
And
gonna
then,
do,
the variables are supposed to be capitalized, right?
What's the filter?
if,
T value and returning one based on
predicate dot call, I guess, I don't know.
Oh, well, you don't worry about that, because it's just the,
Dot test, yeah, dot test.
Also like.
Or, I'm sorry, X.
Equals true.
And then outside of that, we can just, we can just say. Dot.
Outside of the block.
Oh, right here.
Oh, you said outside of that.
No, right here. Yeah.
Doesn't it say
Brackets again.
Maybe it doesn't like, the braces
it
actually.
defines a test.
Yes.
No.
Well, I'm using that list.
yeah,
No, no.
No, they're not.
If.
we have to specify the variable, so you could do like.
Maybe they did.
No.
Yeah, you need to run this.
Aren't you gonna need to do a list one?
So,
But
right
you need to print this right
there, yeah.
The base, and then.
And you need to
Let's get rid of that other predicate.
And it's gonna ask you to have a.
Is
That's it.
the value.
So just return, no, next line just returns the list.
Yeah, you want.
Oh, for testing it's lowercase.
Why is it?
Right there.
Yeah, right there. And then now, next line, return.
Right, so it's,
Doesn't let.
That's because it doesn't like.
oh, because it's a lowercase t.
Well, you need to return.
No, I had a lowercase t for my method.
Or you could do
Yeah,
list
Doesn't like sound.
for each. Actually, you could have done this online. You could have done return Y8 and then do it to collector and use dot collectors.
Static.
Or you could do it this way and not complicated.
Where's that?
Collectors dot collector.
So I have to.
List.
Static is.
Right? No, I'm just saying.
I would.
Right? You can use a collector.
Maxes.
Do it in one line. He knows.
No,
Of course he knows.
Of course he knows, he's the teacher.
Well,
Collector. Static. Build.
I think that works. Yeah, I
Yeah,
like
that
that.
works. Okay, next one.
It's readable for my small brain.
Wait. They create a new list of values 110, they call it filter.
So it
That's
probably
the
is capitalized.
predicate function. So, go to main,
Test.
it doesn't really matter. Like, you don't keep like a, yeah,
new line 7 again.
like if you're going to be capitalizing. First letter is good.
Is it?
Keep that throughout. I just keep the style guide.
What is
Black.
for I, need it for
If you want to filter it at interface, I think you're gonna want to make another
because we need to fill it with.
job file.
Outside.
Yeah.
Another job.
Oh.
A whole separate file.
Not at I.
Good. So the predicate interface should look like this. Why do we have T here, right?
Generics.
Because it's generic, right? Sometimes we want to pass to test an int, sometimes a float, right? Can create a test even with a string, right? It can be anything. But we know that test should return a Boolean. So this predicate interface is basically defining a type of a predicate function that takes one parameter. Only works with one parameter. Now I want to implement the filter functionality. So filter takes a list. So this is a manual implementation of a filter. So filter takes a list, a collection, input list, let's say of integers, and will require a predicate of type integer because it will operate on the items in this given list, right? And we'll test if each item passed the test, then it goes to the output list. So first I create the output list and I run a loop, looping through each of the input list elements. And at each iteration, I'm going to call test implementation from my predicate function. And if this test returns true, when applied to the element, I'm going to add the element into the output list. And then I return the output list. How would I use this filter function? Here's an example. I have a list with 10 values, 10 integers, and I'm going to call filter passing the input list. And here I decided to create a predicate object, right? So it's type predicate that simulates a function. So the predicate implementation here has to define the code for the test, right? Because the predicate is an interface, so I need to provide the code for tests. I override the test method. So this is how my test, what test I'm going to use. I want to check if the number is even or not. This is how I specify the test. Okay. And this is the output, 2, 4, 6, 8, 10. Okay. When I display the output. Well, I'm showing you this implementation, but you shouldn't do that because simple functions like this test function, you can write that in a single expression, right? So let's try to, instead of having to use this I don't know, AR-15 to kill an ant, let's do something simpler, right? Using lambda function, okay? So how would you express that using a lambda function? Look at the syntax for lambda in Java. It takes one parameter, lambda is a keyword, colon, and then the expression. So let's try to express that using a lambda function instead. Right? So lambda some x, you have to name the parameter, and we just need to check if x modulo 2 equals to 0. Oh, it's an arrow, right?
You don't need lambda, do you?
Am I doing something wrong
I
here?
don't think you need lambda keyword.
Oh, this is in Python. I'm so confused. Where is language of Java? Here, right? Okay, okay. So in Python you use lambda, not in Java. Okay, X, and then the arrow. Okay. There we go. Okay, so much easier, right? You didn't have to use because the function was so simple that you can express it using a single line, a single expression. So that's a perfect case for a lambda function. Okay. If you had something more complex that required more than one statement and you can't express everything in just one single line, a single expression, then that would require you to write the function. And the way you write the function is by creating those interfaces. All right, so 2 implementations. Maybe I should leave both implementations here. You guys can use as a reference. This is one possibility. I'm gonna write here now using lambda function syntax. Okay, as you can see, we got the same result. So just understand that this internally is going to be translated into this. Okay? But you don't have to do all that. You just need to write like that. Now using the string package. Well, what is the advantage of using the string package? You don't have to write the implementation for filter. Okay? So filter, map, reduce, right? All the and many more are already available in the string package. So let's use filter from the string package. How would you use it? First, you need to get a stream from your inputs collection. This is what I'm doing here. And then from the stream, from the input stream, I call filter, right? And I just need to pass the test, right? For the test function for the filter. Basically, this is exactly what I wrote here. Okay, so the same thing. It also works, but it's what is returned is another string, the output stream here. I'm using for each to do something with each of the values. Perhaps I'm going to use print, and I'm going to show the values, one value at a time. I'm just going to show them separated by space. All right, so all of them produce the same thing. Now, of course, this is the preferred way. If you have the need to do functional programming in Java, make sure you use streams. And you don't have to reinvent the wheel. Everything is already implemented. Just use the stream package. Okay. For example, instead of using, what if I want to do get rid of this. What if I want to do a summation of all these values here using reduce, for example? How would you do that? See, all these functions: filter, distinct, map, sorted, reduce. Good. If you look at, this is as a curiosity, look at the signature for filter. Look at that. Predicate, so that's an interface, right? Of type integer. And the output is a stream of integer. Well, let's use reduce.
Why does it say super?
This is saying that it has to be integer or any specialization of integer. That's my interpretation here. So let's use reduce. So we can use just, I don't know this first parameter, identity. But perhaps we can use this one here, that we just need a binary operator. This identity here, it looks like this reduce. To me, it looks like fold, right? Because it takes the first parameter. Let's try to use this one here. We need a binary operator based on integers. So it's a function that takes two parameters. We can use a lambda function to do that. So how about reduce? If I have more than one parameter, I have to put in a tuple, right? So x and y. And I just want to add them, right? It's saying that outs is a optional integer, not stream integer. So let's use our ints.
You make an option from ints.
And the problem is with the output. So this worked. Didn't like, so outs is a stream of integer, but it's being returned an optional integer. Oh, okay, reduce, sorry about that. Reduce returns a number, right? Not a list, right? So what we need here is a number. So let's say results. Needs this optional integer. So let's create this optional integer. Optional integer. Okay. Okay, we got something here. So let's try to print this optional integer result. Example using these. Okay, so I can't reuse the stream. Let's use the outs one.
Comment out the previous one.
I already use outs too. Let's just recreate the ins stream. Let's just call this again. Let's try to get from ins. Okay, so we got optional 55, and 55 is the summation of these numbers, right? From ins, right? It's the summation of ins, and ins is from 1 to 10, right? So 1 to 10 added all of them is 55. Okay, so this illustrates how to use reduce and some of the functional programming, higher order functions in Java. I think you guys have any questions about functional programming uses in Java? I can share this code and you can use it as a reference, okay? Let's take a look at how to do the same thing in Python, just to finish our coverage of functional programming today. First of all, lambda functions in Python. So now we use the keyword lambda that I was trying to use earlier. So lambda, the parameter name, right? And then colon the expression. Or the keyword, one or more parameters separated by comma, and then colon and the expression. So how would you use functional programming to use a similar example, to run a similar example? So we had the list from 1 to 10. So first I'm creating this list here using range. So if I print the list, I get this list from 1 to 9. Yeah, so 1 to 10, less than 10, right? So let's say I want to create a new list by having each of the elements of the original list multiplied by 3. So I can easily do that using map. So the map function is available, Python 3. So map, you pass the function, right? So we're passing here the lambda function. So lambda x, the implementation is this expression, x plus times 3. The second parameter is the collection. Map returns a map object. Okay, so this map object, I can get back a list from this map object by calling list on this map object. So that will give me 3 to 27, what we would expect. Okay? So very similar. I don't know if you guys want to try that, but it's very straightforward to do that in Python. Using filter, for example. Look at that. If I only want the even numbers, so I can use filter, pass a lambda function that is a predicate. And the new list here, it will only return the even numbers. I don't see a lot of code using, have you seen code like that? Using Python, using function programming?
I just had to do a project where I used a lambda function
Really?
in information algorithms class.
But have you seen filter and map before? Like, because the first thing I would do if I had to do something like that is list comprehension, right? It comes right in my mind when I try to do this type of thing. I think in Python it's more natural just to do list comprehension because I think it came first, right? I think this is a newer addition to Python, and I don't see a lot of code using function programming like that in Python. If you want to use reduce, for example, you have to import the functools module. So I want to perform a simple summation here like we did. So lambda with 2 parameters. So we pass that to reduce. We need to import reduce. We don't need to import filter and map, but reduce, we need to import this module. And evens only is the list, and that returns a result. We can print the result. And this is being added from 6, these numbers here. That's why we got 60, not 55, to the previous example. This is being applied to this collection here. Okay? So, I mean, I just wanted to illustrate to you guys that function programming you're seeing now embedded in many programming language, popular language like Java and Python. They incorporated function programming features and expect that to become something that you're gonna see in most programming languages. So features that incorporate this type of the ability to work functions as expressions and like having types and being able to pass function definitions to higher order functions that operate or are customized using those parameter functions. All right, cool. Kind of that ends our approach on our coverage of function programming. And today I want to start logic programming. Starting logic programming, everybody needs it.
Great.
So slides, new slide set, slide 14. So logic programming is based on positional calculus, which is a branch of logic based on propositions and relations between them. So what is a proposition? Proposition is a sentence that has a true or false evaluation, so something that evaluates to true or false. Well, that sounds like a predicate, but when we say predicate, we expect predicates to have input variables, right? But we can define simpler propositions, just a statement, like I'm saying something like it's raining, right? That's a proposition. Can be true, can be false, right? Something that doesn't require any input variables, input parameters. In the theory of propositional calculus, we also talk about axioms. So axioms are propositions, established propositions that we accept without a formal proof. Okay, so they are self-evidently true. Sometimes they call them postulates. Here are some examples of axioms from the set theory, things that we don't prove, like there is an empty set, there is an infinite set, right? Those things are very abstract, and when we need to start some theory, we need to start with something, right? And we build the base of our theory, and we assume that those things are true, we believe them, and then we build on top of those postulates, right? That's how most of the theory, math and physics, how they were built. Okay, so based on those axioms, we start to create more generic propositions that are not self-evident and require some proof. So they can be proved using reasoning and logical thinking. So those are theorems. So the axiom for prime numbers defines what is a prime number. So a prime number is a whole number greater than 1 that can only be divided by itself and 1. So the theorem is 5 is a prime number. Okay. So how can I prove that? Oh, let's start dividing 5. Well, 5 is a whole number. Okay, it's greater than 1. Can I divide 5 by 2? No, I can't divide 5 by 3. I can't divide 5 by 4. Yeah, so 5 is a prime number. Okay, so I was able to prove that 5 is a prime number. So facts are propositions that can be used to state something or to specify simple relations between objects. Okay, so those are also called assertions. Here are some examples of facts. So facts, they're kind of like, oh, for us, it's just going to be like facts. They're going to be like similar to, they're not axioms because usually axioms don't depend on others, and you can define facts based on other facts, right? So, but basically the facts in our more like logic programming, they're going to be used to define what we believe is true. Okay, so facts, for example, is sunny. So this fact doesn't it doesn't relate any. It doesn't create a relation between objects, right? So it's just a fact. It's sunny. But on the other hand, this father is a more interesting fact because it relates to objects, okay? John and Mary. It's almost like the fact has input parameters, right? You can think like that. So father, John, Mary is basically saying in the order here, who's the father, who's the son or daughter? We're going to assume that the first one is the father and the second one is the son or daughter. So John is Mary's father. Age, John, 35. We're also relating things because we're associating those two things. Like John is 35 years old. Okay, so basically, we use facts in logic programming to express things that we believe are true. That's how we build what we call our knowledge base. Knowledge base is a set of facts that we start with and we assume it's true. And it has to be expressed in a way that that is clear, right? And doesn't create any ambiguity, right? So if you, or multiple interpretations, okay? So if I say age John 35, we all have to agree that what I'm saying here. And of course, we need to document the fact in order to clearly specify what this fact is about. Is it about, well, the name of the fact, it helps, right? Age, so John is a name. We know that John is a name. 35 is a number, right? So we can infer, based on the names we're using here, that we're saying that John is 35 years old. But sometimes we need to clarify, like father, we need to document this fact and say that, okay, this is going to relate two people, and the first one is going to be the father of the second object, okay? Okay, so far, are we good with these definitions? Okay. So facts are propositions, right? And a proposition is a sentence that has a true or false evaluation. So let's look at how we build propositions, okay? And this is all based on Prolog syntax. So Prolog is a well-known and old logic programming language, okay? We're going to use Prolog as an example of logic programming. So in Prolog, Prolog call propositions, also called terms. You can define them as simple or compound. So the simple, those were all simple here. Okay, so it's basically just facts, sometimes simple facts, just the name here, or sometimes the fact has a name and has parameters associating objects. So those are simple facts. But you can also create, so simple terms, right? You can also create compound terms where you define a term by negating another term, right? So if you put a not before is sunny, so you're creating another term that is a negation of what is sunny is saying. So if sunny is true, we assume that is sunny is true, not is sunny is of course false. We can do conjunctions, we can also do disjunctions. So Conjunction basically is using an and. So if you connect two terms or more using the and, you're creating a compound term. You can use or. You can also use implications. So implications are more complex because only if something is true, we imply something else, right? So it's the if-then type of relationship. So specific in logic programming, or how logic programming works. Basically, you don't give in logic programming, and this is the main reason why we studied logic programming is to show you a completely different paradigm than what we're used to, right? Because so far, we are used to writing a program by specifying a set of steps, right? What your program needs to do. Or we need to specify how to achieve that goal, right? So we need to specify those steps. And this is normally assumed when you write a code. When you try to solve a problem, you specify the steps. But in logic programming, there's a big shift on how you specify the solution for your problem. Because logic programming advocates that knowledge about the problem, so you feed your program of all information you can build, and assumptions, so things you can assume that is true, and they should be sufficient to solve the problem. And that's the only things we need to provide to the computer. So basically, you provide facts and you provide relationship between objects, and then you ask questions. And the runtime of your logic programming language should be able to answer those questions based on the information you fed initially to your program. Okay, so what is actually a program in logic programming? So a program in logic programming is defined as a set of sentences in a goal statement. So the goal statement is what you want to learn from this program. Okay, and the set of sentences are facts and relationship and rules that can be used to reach that goal, right? To prove that goal to be false or true or false. So Prolog, as I mentioned, is a logic programming language. It's going to be used to illustrate how logic programming works. Okay, so think of that. It's more like a curiosity of how a completely different paradigm than what we used to, because you don't specify all the steps to get to the solution. You give a set of sentences, usually called knowledge base, that contains facts, things that we assume that they are true, and also rules that can be applied to the facts to learn new facts. Okay, and based on that, your program is basically trying to solve or answer a question. That's the goal statement, is basically something that you need to prove true or false. So looking a little bit closer to how you express facts in Prolog, I already show you this type of fact. So it has a fact has a name and has potential parameters. Okay, so the name, because this fact, right, has parameters, is a predicate. So this is the father is a predicate, it's the name of the fact. And those are the parameters or arguments passed to the predicate. There are some predicates that are built in, like the is. So is, it's going to be used to assign values, not assign values, sorry, to check if a variable has a specific value. So for example, if I want to check if x equals to 5, I'm going to use this predicate called is. It's a built-in predicate in Prolog that will return true if x equals to 5. Okay. By the way, in Prolog, variables are always start with a uppercase. Okay, so that's how we differentiate variables and predicate names or constants, right? For example, John, if I write John using lowercase, Prolog understands that's a constant. But if I write using, I capitalize John, Prolog thinks it's a variable. Okay, so this is a literal. So that's the first thing you need to understand to write code in Prolog. Okay. You have also built-in arithmetic predicates if you want to do additions here, right? Let's say, well, arithmetic, those are binary operations, right? But they're not predicates, right? So those are arithmetic. You have to use in conjunction with some predicate in order to check if the value is true. Because in Prolog, everything you have to ask Prolog whether if it's true or false, right? So what you need to do is, for example, you want to add 5-2, you can add 5-2, and then you can ask what's the result of 5-2. So this is also what we're going to use. So if the question is x is 5 plus 2, the answer, Prolog will try to answer that in order to make that true. And by trying to prove that x is 5 plus 2, it will tell me that x is 7. Okay, so do you understand that it's like a I want to print the value of 5 plus 2, right? But Prolog, everything needs to be formulated as a true or false question, right? So in order to get the value of 5 plus 2, I have to do all this workaround, right? So I have to do x as a variable. And the question is x is 5 plus 2? And the Prolog will say yes, x is 7. X is 7 because this is the only way to prove this true, right? We're going to see examples of using that to prove simple things as true. Then you have the relational operators. Anything out of the ordinary here? I guess the different, right? See, the symbol is equal / equal. So that means they do not have the same value. Let's try to use some examples. The Prolog environment that I encourage you guys to use, it's available online, so you don't have to install anything. think it's SWIPL. It's SWI prologue. If you go to swi-prologue.org, you can use this one here. Try SWI prologue online. Okay, so it's the swish. Okay, so prologue interpreter that we're going to be using is the swish swi-prologue.org. Sorry, I missed SWI. Swish dot SWI dash prologue.org. Okay. So you can open a program, you can write your code here, or you can just type your quick queries here. So if I do like the example I was talking about, x is 5 plus 2 dot, if I try to run this, okay, I get the answer 7. Okay, so if I do 5 plus 2, give me 5 plus 2. Oh, 5 plus 2 is a number. It's not true or false, so you don't get any. Okay. And if you do x equals 5 plus 2, you're basically saying that x variable is assigned 5 plus 2, but you don't get the value, right? So you need to formulate that, as I said, as a true or false question. So programming Prolog, you're going to state facts. Like, for example, if you say it's sunny, dot, right? This is a fact. Now I can say it's sunny. It tells me that it's true, right? Because it's already processed this program and already knows that it's sunny. So it's sunny is true. If I try not is sunny, it's the not operator. Oh, I think it needs to pass inside parentheses. Okay, so not is sunny is false. The negation already knows that it's sunny, so not is sunny is false. And if I want to relate things like we were talking about, Father, John, Mary, so it's read, it's already processed. I can, for example, I want to know who's Mary's father. So I can formulate that as a question using a variable. So Prolog will answer my query trying to make this true. In order to make this true, the only possibility for x is John. So you should answer as John. Okay. I can do things like who's John is whose father? And I get there. So let's go back. Well, there isn't, just by using these facts, you can't do much, right? Basically, you're just going to state a bunch of facts, and you're going to ask question about those facts. Prolog would be really dumb, not be very useful. What is interesting is things become more interesting when you add rules, like implications like this one, right? So the syntax has two parts, the head and the body. So the head is a fact that is only true if the body is also true. Okay, so you have to read this as from right to left. Okay, so head is going to be true only if the body is true. So for example, you have the fact rainy. It says it's raining. And sun is out only if it's not raining. So you can create this implication, you learn a new thing. You can also use the conjunction, right? In this case, a disjunction. I always get confused with these two operators. In Prolog, the semicolon is disjunction. Okay, so X is a mammal, and look at this rule. We're using variables here. Okay, so basically, what you're saying is that if X, and X can be anything, right? If X is a dog or X is a cat, we can imply that X is a mammal. Okay? So semicolon is for disjunction, and the comma is for conjunction, the and. So this is an or. Query provides a way to retrieve information from a logic program. Ask whether a certain relation holds between objects. So you're not going to use question mark because SWI Prolog use dots for stating facts and applications and everything, and also use dot to ask questions. So, but you may see in books, if you are more into Prolog and you want to read more about it, you may see the use of the question or when you ask questions about something. So synthetically, facts and queries, they look the same, but they can be distinguished by the context. Okay, so I don't even know if SW Swish accepts questions. Let's see. Yeah, it doesn't even recognize questions, so don't worry about the question mark thing. So a logic program in Prolog consists of one or more clauses, where each clause can be facts and rules. So clause basically involves everything, facts or rules. Rules are a combination of facts using implications, conjunctions, disjunctions. So here's a more complete example. You have this family tree, okay, and you want to write a program that will represent this family tree and allows you to ask questions about the relationship between these people. Okay, so this is a typical Prolog program to represent this simple relationship between these objects. So we start with facts about fatherhood. So we're saying that David is John's father, is also Lisa's father. Jack is Susan and Ray's father. Then we have John is Peter and Mary's father. And then we're going to start creating motherhood relationships. And then for parents, I want to use variables because I don't want to do all the facts about parents because they can be implied or represented using a rule. So parent, X is going to be Y's parent. There are two possibilities. So I'm going to create two rules here. Father X, Y. So X is Y's father or X is Y's mother. If any of these are true, parent X, Y is going to be true. And X and Y can be anything. And we also can do something called indirection. So I can create indirect rules that shows a little bit more advanced prologue.
Can you combine those parent rules into one with the semicolon? Does that work there?
Also works.
Okay.
If you want to use or, you can put in just one line combined with or. Okay, one with a column. Okay, and indirect, why is this an indirect rule? Because I'm adding a third variable here. Did you notice the z, right? So basically, x is the grandfather of y if x is the father of some z, right? Some person z, and this z is a parent of y, right? So that allows us to create indirection, okay? Relationships. As an exercise, why don't you guys code that? Use the switch prologue and type this in, so you get a little bit familiar with
Zoom in
prologue
on it a
syntax.
little bit so that I can. Can you zoom in on that a little
Yes. Can you read it?
Yep. Thank you. Got a random question about prologue. So I was putting spaces between the two parameters for father. It's not going to care about the white space. Okay.
We can't copy paste.
Looks so crisp and clean.
So we can do a few. If you skip to others. Use the same to like yeah, we need a John.
There's some kind of smudge on that screen, so it looks like pixel.
That's a cursor.
That is.
Okay. So I guess I don't know, because right now we're saying David
Like,
and
who is
Amy have two kids called John and Lisa. I think it's Karen. So I guess we need all. Okay, never mind. Yeah, just do them all. I like this. I'm building right now. Squat it out. So we can double this. So we can just do that. So separate it. We need a period. Yes. Just a minute. Or uppercase makes.
This is actually now that we've covered all of these, it's actually what you just asked. Not quite.
It's just mother instead of.
Susan is not a father.
No.
Right, but it's saying grandfather equals Susan.
No, it's saying.
Is that how that works?
Yeah, it's asked backwards. Yes.
So then that's saying Jack is Susan's grandfather.
So now.
So then if I say
Oh, actually, just put the.
grandfather X Susan, I'm gonna get Jack.
What? Yeah. Yeah, so it's exactly.
It says false. It says false.
Grandfather is how. Grandfather is.
So how would we say that?
This. This.
Yeah, that's the error.
Or Dave that you throw in here.
No.
And you could also do like parents. Yeah, it could be on either side.
Run.
But I think you need parents right?
And Suzanne.
It's doing something.
That's some kind of output.
Awesome.
Okay, so
We can ask if.
Oh, I
it's false.
Let's just make a third person. Like between 12 and 13.
You figure out what my code is.
You didn't.
I don't know if this is.
Sad Larry. It should definitely be Sad Larry.
Do mother.
I really appreciate it. Sure. You know, use it.
And so
Yeah,
show
Sarah.
David as the
Yeah,
grandfather.
Teresa, yeah. Teresa.
Which is.
So what does it mean? Like
Teresa's
multiple
mother.
characters?
Person.
Jack is
Person.
David's grandfather, is Peter's
Yeah.
grandfather?
No.
It's supposed to.
Yes.
So if I want to get Peter's parents, how would you ask that question?
Oh, he has two grandfathers. Okay, yep, okay.
So the first parameter, I use a variable, right? That's what I want you to find out. Peter. And the first answer was John, and I can
John and Susan.
I think I have to use some sort of add.
You're not gonna find anything out.
Try to remember how to get.
There's
Oh, I have an arrow here.
Teresa's got that data.
That's great.
Okay, so now we
Yeah,
have,
Teresa our data.
you can click next, right? And now I got Susan. I want to find out grandfathers of Peter.
Amy is a father.
I think some
Try to at least knock it. Some.
It's Liz, it's mother. So I messed up here.
I'm assuming the opposite way, knocking out height, size, and search.
So starting here, I started to mess up. Mother,
I still need recursion on it.
Oh, big X. That's what I use when I was very, sure you can do it without that.
So how similar, because you said
okay, so David and Jack.
So just block that.
Alright, so that makes sense. David and Jack using the indirect relationship, okay? Alright, I know you guys are getting really excited about co-op, but it's getting late. We continue on Thursday.
Oh yeah, class is over, huh?
You see, you didn't even realize that was
It was so much fun.
I'm surprised. You guys are enjoying co-op. I'm really impressed.
I don't know, it's genuinely actually kind